Section 5.1 Introduction to Decimals. In this video we will see the definition of digits and how to write a number in decimal notation, how to pronounce a number in decimal notation, how to read a number in decimal notation, how to convert a decimal number to a fraction, how to round a decimal number with a rounding and test digit, how to compare positive decimal numbers, and how to compare negative decimal numbers. Recall that whole numbers are constructed by using digits. The set containing whole numbers 0 to 9 is called the set of digits. As an example, the whole number 55,555 is constructed by using a single digit. However, the position of the digit 5 determines its value in the number 55,555. The first occurrence of the digit 5 happens in the 10,000s place, so its value is 5 10,000ths, or 50,000. The next occurrence of the digit 5 is in the thousands place, so its value is 5,000ths, or 5,000. Indeed, the whole number 55,555 in expanded form is 50,000 plus 5,000 plus 500 plus 50 plus 5, which reflects the value of the digit 5 in each place. Decimal notation. In Table 5.1, each time you move one column to the left, the place value is 10 times larger than the place value of the preceding column. Vice versa, each time you move one column to the right, the place value is 1/10 of the place value of the preceding column. Now consider the decimal number, which consists of three parts: the whole number part, the decimal point, and the fractional part. The whole number part of the decimal number is the part that lies strictly to the left of the decimal point, and the place value of each digit in the whole number part is given by the column shown in Table 5.1. The fractional part of the decimal number is the part that lies strictly to the right of the decimal point, as we saw in Table 5.1. Each column has a value equal to 1/10 of the value of the column that lies to its immediate left. Thus it should come as no surprise that the first column to the right of the decimal point has place value 1/10, the second column to the right of the decimal point has place value 1/100ths, the third column to the right of the decimal point has place value 1/1000ths, and the fourth column to the right of the decimal point has place value 1/10,000ths. Pronouncing decimal numbers. The decimal number is made up of 1/10, 2 ones, 3 tenths, 4 hundredths, 5 thousandths, and 6 10,000ths. It can be written in expanded form as 10 plus 2 plus 3 over 10 plus 4 over 100 plus 5 over 1,000 plus 6 over 10,000. Note that the whole numbers can be combined and the fractions can be written with a common denominator and summed. So 10 plus 2 is 12. 3 over 10 can be written as 3,000 over 10,000 by multiplying by 1,000. 4 over 100 can be written as 400 over 10,000 by multiplying numerator and denominator by 100. 5 over 1,000 can be written as 50 over 10,000 by multiplying numerator and denominator by 10. And 6 over 10,000 doesn't change since our common denominator is 10,000. Adding all our numerators together, we get 3,456 over 10,000. The result tells us how to pronounce the number. It is pronounced 12 and 3,456 10,000ths. Example 1. Place the decimal number in expanded form. Then combine the whole number part and sum the fractional part over a common denominator. Use the result to help pronounce the decimal number. Solution. In expanded form, the decimal number becomes 1,000 plus 200 plus 30 plus 4 plus 5 over 10 plus 6 over 100. Sum the whole number parts, and express the fractional parts as equivalent fractions and combine over one common denominator. 1,000 plus 200 plus 30 plus 4 is 1,234. 5 over 10 becomes 50 over 100 when we multiply by the numerator and denominator by 10. And since our common denominator is 100, we won't change 6 over 100. Then 50 plus 6, the sum of the numerators, is 56. Hence, the decimal number is pronounced 1,234 and 56 hundredths. Example 2. Place the decimal number in expanded form, then combine the whole number part and sum the fractional part over a common denominator. Use the result to help pronounce the decimal number. In expanded form, the decimal number becomes 50 plus 6 plus 1 over 10 plus 2 over 100 plus 8 over 1,000. Sum the whole number parts. Express the fractional parts as equivalent fractions and combine over one common denominator. 50 plus 6 is 56. The common denominator is going to be 1,000, so we'll multiply 1 over 10 by 100 over 100 to get 100 over 1,000, 2 over 100 by 10 over 10 to get 20 over 1,000. Then Adding the numerators 100 plus 20 plus 8 is 128. So we're left with 56 plus 128 over 1,000. Thus the decimal number is pronounced 56 and 128 thousandths. The discussion and example leads to the following result. How to read a decimal number. Pronounce the whole number part to the left of the decimal as you would any whole number. 2. Say the word "and" for the decimal point. 3. State the fractional part to the right of the decimal as you would any whole number, followed by the place value of the digit in the rightmost column. Example 3. Pronounce the decimal number. Solution. The rightmost digit in the fractional part of the decimal number is in the hundredths column. Thus, the decimal number is pronounced 34 and 12 hundredths. Important point. In pronouncing decimal numbers, the decimal point is read as "and." No other instance of the word "and" should appear in the pronunciation. Example 4. Explain why 434 and 2/10 is an incorrect pronunciation of the decimal number. Solution. The decimal point is read as "and." No other occurrence of the word "and" is allowed in the pronunciation. The correct pronunciation should be 434 and 2/10. Example 5. Pronounce the decimal number. Solution. The rightmost digit in the fractional part of the decimal number is in the thousandths column. Hence, the decimal number is pronounced 5,678 and 123 thousandths. Example 6. Pronounce the decimal number. Solution. The rightmost digit in the fractional part of the decimal number is in the 10,000ths column. Hence, the decimal number is pronounced 995 and 4,325 10,000ths. Decimals to fractions. Because we now have the ability to pronounce decimal numbers, it's a simple exercise to change a decimal to a fraction. For example, the decimal number is pronounced 134 and 12 hundredths, so it can easily be written as a mixed fraction, 134 and 12 over 100. But this mixed fraction can be changed to an improper fraction. 100 times 134 plus 12 gives us 13,412 in the numerator. Placing that over the original denominator, we get 13,412 over 100. Note that the numerator is our original number without the decimal point. There are 2 decimal places in the original number, and the denominator of the final improper fraction contains 2 zeros. This discussion leads to the following result: changing decimals to improper fractions. To change a decimal number to an improper fraction, proceed as follows. 1. Create a fraction. 2. Place the decimal number in the numerator without the decimal point. 3. Count the number of decimal places. Place an equal number of zeros in the denominator. Example 7. Change the following decimal numbers to improper fractions. Solution. In each case, place the decimal number in the numerator without the decimal point. In the denominator, add a number of zeros equal to the number of decimal places. The decimal number 1 and 2,345 10,000ths has 4 decimal places. Hence, the decimal number equals 12,345 over 10,000. B. The decimal number has 3 decimal places. Hence, the decimal number equals 27,198 over 1,000. Example 8. Change each of the following decimals to fractions, reduce to lowest terms. Solution. Place each number in the numerator without the decimal point. Place the number of zeros in the denominator equal to the number of decimal places. Reduce to lowest terms. A. First place 35 over 100. So 0 and 35 hundredths equals 35 over 100. We can divide both numerator and denominator by the greatest common divisor. The greatest common divisor is 5, so dividing the numerator of 35 by 5, we get 7 in the numerator. Dividing the denominator of 100 by 5, we get 20 in the denominator. The resulting fraction is 7 over 20. B. 0 and 125 thousandths. First place 125 over 1,000. Then prime factor and cancel common factors. 125 in the numerator is equal to prime factors 5 times 5 times 5, and 1,000 in the denominator is equal to prime factors 2 times 2 times 2 times 5 times 5 times 5. The numerator and denominator have 3 5s in common, so we will cancel those, and we're left with 1 in the numerator and 3 2s in the denominator, which leads to the reduced fraction 1 over 8. Rounding. The rules for rounding decimal numbers are almost identical to the rules for rounding whole numbers. First, a bit of terminology. Rounding digit and test digit. The digit in the place to which we wish to round is called the rounding digit, and the digit that follows on its immediate right is called the test digit. If we want to round the decimal number to the nearest hundredth, then the rounding digit is 5 and the test digit is 4. If we use the rules for rounding whole numbers because the test digit 4 is less than 5, we would replace all digits to the right of the rounding digit with zeros to obtain the following approximation. 12 and 254 thousandths approximately equals 12 and 250 thousandths. However, because 12 and 250 thousandths equals 12 and 250 over 1,000 equals 12 and 25 over 100, the trailing zero at the end of the fractional part is irrelevant. Hence, we truncate every digit after the rounding digit and use the following approximation. 12 and 254 thousandths approximately equals 12 and 25 hundredths. Important observation. Deleting trailing zeros from the end of the fractional part of a decimal number does not change its value. The above discussion motivates the following algorithm for rounding decimal numbers. Rounding decimal numbers. Locate the rounding digit and the test digit. If the test digit is greater than or equal to 5, add 1 to the rounding digit and truncate all digits to the right of the rounding digit. If the test digit is less than 5, simply truncate all digits to the right of the rounding digit. Example 9. Round 8 and 7,463 ten-thousandths to the nearest hundredth. Solution. Locate the rounding digit in the hundredths place and the test digit to its immediate right. Because the test digit is greater than 5, add 1 to the rounding digit and truncate all digits to the right of the rounding digit, hence to the nearest hundredth. The decimal number approximately equals 8 and 75 hundredths. Example 10. Round the decimal number to the nearest tenth. Solution. Locate the rounding digit in the tenths place and the test digit to its immediate right. Because the test digit is less than 5, truncate all digits to the right of the rounding digit, hence to the nearest tenth. 113 and 246 thousandths approximately equals 113 and 2/10. Comparing decimals. We can compare two positive decimals by comparing digits in each place as we move from left to right, place by place. For example, suppose we wish to compare the decimal numbers 5 and 234 thousandths and 5 and 2,357 ten-thousandths. First, add enough trailing zeros to the decimal number with the fewer decimal places so that the numbers have the same number of decimal places. In this case, note that 5 and 234 thousandths equals 5 and 234 over 1,000 equals 5 and 2,340 over 10,000ths equals 5 and 2,340 ten-thousandths. Important observation. Adding trailing zeros to the end of the fractional part of a decimal number does not change its value. Next, align the numbers as follows. As you scan the columns moving left to right, the first place that has different digits occurs in the thousandths place, where the digit 5 as the second number is greater than the digit 4 and the first number in the same place. Because 5 is greater than 4, the second number is larger than the first. That is, 5 and 234 thousandths is less than 5 and 2,357 ten-thousandths. This discussion suggests the following algorithm. Comparing positive decimal numbers. Add enough trailing zeros so that both numbers have the same number of decimal places. Compare the digits in each place, moving left to right. As soon as you find two digits in the same place that are different, the decimal number with the greatest digit in this place is the larger number. Example 11. Compare 4 and 25 hundredths and 4 and 227 thousandths. Solution. Add a trailing zero to the first decimal number and align the numbers as follows. The first difference is the hundredths place, where the digit 5 and the first number is greater than the digit 2 in the same place as the second number. Hence, the first number is larger than the second. That is, 4 and 25 hundredths is greater than 4 and 227 thousandths. When comparing negative numbers, the number with the larger magnitude is a smaller number. Hence, we have to adjust our algorithm for comparing negative decimal numbers. Comparing negative decimal numbers. Add enough trailing zeros so that both numbers have the same number of decimal places. 2. Compare the digits in each place moving left to right. 3. As soon as you find two digits in the same place that are different, the decimal number with the greatest digit in this place is a smaller number. Example 12. Compare negative 4 and 25 hundredths and negative 4 and 227 thousandths. Solution. Add a trailing zero to the first decimal number and align the number as follows. The first difference is in the hundredths place, where the digit 5 in the first number is greater than the digit 2 in the second place of the second number. Hence, the first number is smaller than the second. That is, negative 4 and 25 hundredths is less than negative 4 and 227 thousandths.